Hello everybody, this video is about base rule in R. So we have the base rule here, or base theorem as we call it. We have probability of theta given data equal probability of data given theta times probability of theta divided by probability of data. It's the base rule. And here we have the theta, that is the vector of candidate value for the parameter theta. We have n theta val, which is the number of candidate theta values. To produce this example, we have n. I took here n theta values equal 3. So those are the variables we need to declare here. Then the next, we need the vector of theta values. You have theta equal the sequence from 1 divided by n theta vals plus 1. N theta vals equal 3, so 1 divided by 4, from 1 divided by 4 to n theta vals, which is 3, divided by n theta vals plus 1, so 3 divided by 4, and by 1 divided by n theta vals plus 1, so by 1 divided by 4. So this is the value of theta from 1 divided by 4 to 3 divided by 4 by 1 divided by 4. The next step is to find the probability of theta, which is the vector of prior probabilities of the theta values. So you have the probability of theta equal probability of mean theta 1 minus theta. That makes a triangular belief distribution. Then the probability of theta equal probability of theta divided by sum of probability of theta. This makes sure that the beliefs sum up to 1. It's like kind of normalization. So this is the data we have. This is our data. Data equal the vector C. You have 3 1s and then 9 zeros. So we need first to run everything from n theta vals. We run it. We run theta. We run probability of theta. Now we have our data here. N true equals sum of data. The ones here is for n true. The zeros are for n false. So we run n true. We check and we see n true equals 3. So we have 3 ones. We run n false. We check n false. We are going to have 9. So 9. So our data size is 12. 3 ones and then 9 false. And we are going to compute the likelihood of the data for each value of theta. And the likelihood, you know it, is probability of data given theta, which equal probability of theta to the power n true times 1 minus theta to the power n false. N true equal 3, n false equal 9. Now the next step is to compute the posterior. So know that posterior equal prior times likelihood. So probability of data, you know it here, is sum of probability of data given theta times probability of theta. Is called probability of data equals sum probability of data given theta times probability of theta. And our posterior here, probability of theta given data. This is the posterior. Prior is probability of theta. posterior probability of theta given data. Which is equal to probability of data given theta times probability of theta divided by probability of data. This is our base rule. Again, here we talk about it in the beginning of this video. We come to it here, and we have to run each of them. You already have our prior, you have our likelihood, and we have our posterior. So the next step is to plot. So if you would like to set the layout to have all the three plots in one, that's fine. You can write this code here, the layout matrix C123, number of rows 3 and number of column 1. So you are going to have the three plots in one column, and then you set the number of margins, margin lines, bottom left, top right, by this code. You can change those values if you want, and then the margin lines to use for the labels, and also the margin size in inch for bottom left, top and right. But I would like to plot them differently, so I am going to comment this code. If you like, you can do it. So okay, now we want to plot our prior, sorry. So we have this code plot theta and the probability of theta. Type histogram, line width 3, main, prior. X lim is the limit from, this is the vector 0 to 1. X lab is going to give as theta. Y lim C0 to 1.1 times max of probability of theta given data. The Y lab, the label is going to be probability of theta. Write this code with B code. CEX dot axis 1.2, CX dot lab 1.5, CX dot main 150. So you plot, you run the code, and you have the plot of your prior. You have probability of theta on Y axis, and X axis you have theta. Next is to plot the likelihood. Probability of likelihood you have plot theta, probability of data given theta, and all the remaining codes are the same. Plot type is histogram, the width 3, main, the title of the plot is likelihood. X lim C01, X lab is theta, Y lim, the vector 0 to 1.1 max is exactly the same here. Probability of data given theta, this time it's not probability of theta given data, but probability of data given theta. Y lab is going to be probability of data, PD. And to set the CX, we keep the same values, and we plot, we run the code. So here we have our likelihood, probability of data given theta, and you have theta. Now we would like to add a text here to say that, okay, you have our n true and n false. With the true, with the data, you have the true and the false here. So text 0.5, these are what you need for the text. So 0.55, 0.85 max probability of data given theta, CX2, B code, like in the label you will have D times number of 2 times T times false. So you run it, and the text would appear here. Let me see T. You have 3 false, 3 true, and 9 false, as we saw it in the beginning. So we have our data equal 3 true and 9 false. The next step is to plot the posterior. To plot the posterior, we have plot theta and probability of theta given data. Exactly the same. The title changes here. All the other parameters stay the same, except that we change theta here, we change probability of theta given data, and here we would have the probability of theta given data. And in the text, we need our data, we need the probability of data also. So we run this code. This first part is going to give us the prior plot. This the plot of the prior, have probability of theta given data and the theta. We run the text, which is here, and we'll have exactly the probability of data, which equal 0.000416. So this is the base rule in R with the steps we went through. As you may have learned it in class. I know for sure it was done in class, and this is the practical part of the class. So thank you for watching this video. For those who are using it for their research or their project, thank you.